Hello everyone, I'm Ganti Thaviwat Mongkol and today I'm gonna talk about microservices. Nowadays, in the software industry, you may heard many people talking about microservices, but what are they? If you think about software development, in the simple way, you just develop the application as a single unit constructed. Like when you wanna add new feature, just add more and more until the codes are too complicated to add new feature. And it will be hard to know where to start and what the code is about. And this is a starting point to create an application model called monolithic. Developers have to separate the application into the layers, including user interface, application, business, and data access layer. But it's still not good enough. There are many issues in this model, like it's inflexible, unreliable, unscalable, slow to development, like you must redeploy to entire application on each update, etc. So now, microservice breaks apart of the complex codes into the set of small systems, and most importantly, independent processes. Moreover, in each component can use any language and technology that's suitable with each service, so developers can work in parallel, faster, and more efficient. Long story short, the benefits of the microservice make an application independently deployable and scalable, and reduce downtime through fault isolation, like application can stay up and running even when one of its modules fails. And the last one is smaller code base. That enables teams to more easily understand the code and it makes them simpler to maintain. But there are some challenge issues to design the microservice. Organizations face increased complexity when designing. As I told you that microservice breaks a part of the code into the small service, so you have to struggle to determine about each microservice size, optimal boundaries, and connection points between each microservice. And the last thing is the framework to integrate the service. The next thing I'm gonna talk about is microservice architecture. I will show you an example of the overall design. Firstly, you have various services corresponding to different business capabilities, like breaking the application into the set of mini-services. Then, in each service has its own database. This will be necessary in order to ensure loose coupling. The coupling or dependency occurs when we want to use the information from other service, but we don't want it happen. So just avoid them by creating its own database. Next is an API gateway, which is a server that is a single entry point into the service systems as a facade in the opposite side. As you know, the facade provides a simple uniform view of complex internals to external clients, but for the gateway provides a simple uniform view of external resource to the internals of the application. So all requests from the clients will first go through the gateway. And there are the various clients such as the user from the browser that use the web application or mobile device that also use the mobile application. And this is overall of the microservice architecture. More complexity, more challenges. Next, I'm gonna talk about the domain model. Domain model is a diagram that represents objects in a domain in real situation. Because the complexity when designing and the complex business logic, we can apply the domain model pattern to help us build objects with rich structures and behaviors. This picture is an example of domain model. There are many boxes which represent the objects and lines which represent the behaviors or relations. But there is an issue about the domain model. It cannot easily be partitioned across multiple services, so you can only use it for each partition. Next is ACID transaction. The word transaction is a set of one or more operations that update the database to the new state. If a transaction fails, the database won't be updated. And the word ACID is an abbreviation of the transaction properties in the database management system. And the first letter, A, stands for atomicity, which means the entire transaction takes place at once or doesn't happen at all. C stands for consistency, which means the database must be consistent before and after the transaction. And next is I, stands for isolation, which means multiple transactions occur independently without interference. And the last one, D, stands for durability, which means the chances of a successful transaction occurs even if the system failure occurs. So the thing we need here is something that can be guarantees the consistency. And there is the thing we need is called two-phase commit. The two-phase commit mechanism can be used to ensure the integrity of data in a distributed transaction. For first phase as a commit request, in the first, the coordinator sends a query to commit message to each service involved in the distributed transaction. The services execute the transaction but not commit yet. Then go to the second phase as a commit phase. If all services have replied yes, then the coordinator sends a commit message to each of the services and then commit the transaction. But if at least one service has replied with no, the coordinator sends a rollback message and the services roll back the transaction. It seems a good thing that we can guarantee the consistency by using 2PC, but 2PC is best avoided. The first reason is 2PC is not supported by many NoSQL databases. And the second one is about the CAP theorem, which are C, consistency. When we get all the same data at the same time on each node, consistency is archived. And the second one is A, availability. Indirect availability will mean a high or fast response time as well. If the response time is too long, it will result in clients accessing our system having a bad experience. And the last one is partitioning. A system with high partition tolerance means that the system can still operate even if communication between nodes is disrupted. But a distributed database system can have no more than two conditions that can be fulfilled, so we have to pick two of those, and it's preferable to pick availability over the consistency, and that's why the 2PC is best avoided. And this is all of the first part of the microservice. See you in the next part.